Right, so I guess for anyone who doesn't know about Zego, I'll give a bit of a quick introduction. We've been going since middle of 2016, and really what we the reason we exist is to provide cover that creates possibilities and changes the way people are able to go and work. We started by selling insurance to the gig economy at an hour a time, because if you were a delivery rider or an Uber Eats rider and you wanted to go and work for a couple of hours on a Friday, Saturday night, you couldn't. You had to go and buy an annual 24/7 insurance policy just to be allowed to work. And we said that doesn't make any sense. So we just decided to try and make insurance that really does make sense, and be a true disruptor, I guess, in the sense of the word. My role at Zego has changed many times in the last, what are we up to, 4 years now? Um, but I'm currently a staff engineer. The role of a staff engineer at Zego is really to make sure that, like, on a very technical level, we are moving in a direction that gets us to where we want to be as a company on a longer horizon. So as a software engineer, day to day, it's very easy to get caught up in what is my ticket now? What is this one problem that I'm trying to solve today or this sprint? Or maybe every now and then you look at your current quarterly OKRs, and so you're looking sort of up to 3 months in advance. And it's very easy to go day by day and do the best thing every single day and still not be where you want to be in 18 months' time because you didn't realize you weren't on the right road. So as a staff engineer, myself and the rest of the staff engineering team are responsible for making sure that the way we go about solving problems on that day-to-day basis and for those tickets is aligning us with the wider company vision over the next sort of 18 months. And one of those visions is what I'm going to talk about today, which is telematics. So for those who don't know about telematics, it's basically getting all of your positional behavior, your driver behavior whilst you're actually driving. Traditionally, it was done with black boxes that you would install into cars. But the way society is moving, and certainly the way our customers are moving, people now have incredibly powerful computers sitting in their pocket the whole time while they're driving and while they're working, and that's their mobile phones. And these phones have got accelerometer data, they've got GPS data, they've got all the data that you need to be able to probably understand how somebody drives. And so what we wanted to do as a company was take that data that they have and empower them to understand how their driving will actually impact their risk profile, and then in turn what they pay for their insurance. So be able to feed back to people, you are driving really well, your insurance is likely to come down next time it's up for renewal. Or conversely, hey, listen, like, you're really hard on your brakes, which not only is going to increase your fuel consumption, but also it's going to cause your insurance premiums to go up. And one of the things that we understand there is that data, especially in the current climate of privacy, that data is a currency. For people to share that data with us, they're giving up quite a lot. And so we want to be able to return that. And we return that in a number of ways. One, by offering like the flexible policies and the products that allow them to work. And two, by really being able to provide more value back to them. Everything from fuel consumption and wear and tear on their vehicle through to, like, here is practical steps that you can do to reduce your insurance premiums. So this is not our first foray into telematics. We tried to do this back at the start of 2017. And at the time, there weren't very many app-based telematics companies. So we partnered with a more traditional black box provider who said, if you guys can collect the data on the phone and send it to us, we can do all of our processing to be able to turn that data into a driver score and understand exactly how they drive. At the time, our mobile apps were all based in React Native. And what that meant was that we were trying to collect what is very raw data from the guts of the different machines, and process it in JavaScript and send it off to a server. And the reality was it wasn't good enough. It wasn't good enough for us to use to reliably tell someone how they were driving. And if we weren't going to be able to do that, then we couldn't provide that value. We could collect a whole bunch of data and it would be fantastic. But if we can't accurately assess someone's risk or accurately provide them with how that risk is going to change their insurance, then we weren't going to just drain people's batteries for the sake of it. So we shelved that product back in the end of 2017. I think it might have been December. And we've ripped all the telematics out of our app and said, we're just going to put this on hold. We know that this is really important. We know that understanding how you drive is really important to our users, but the technology that we were using at the time wasn't good enough. So if we fast forward to this year, to today, when we decided that it was time to have another stab at this, we started to rewrite our apps in native code rather than React Native, which what that did was gave us better access to that raw data and allowed us to really start to collect it and process it on the device without chewing through people's batteries. And we were able to partner with very experienced app-based telematics companies. So using some of their core technologies, using their SDKs and plugging it into our app. And then what that gave us is not only the experience that they had got over the last couple of years from processing app-based data, but meant that rather than solving the challenges of how do we process that data on a phone and get that data to the server, we could start to solve the challenges that were more important to our users, which is how do we provide value then back to them? And some of this is in like pretty user interfaces. Some of this is in nice graphs and charts and scores and, the gamification of, you've got more points than your friend has got for that day. But also it comes into how do we start to use that data to actually affect your premium? For those who know much about insurance, you go to a comparison website, you fill in 50,000 different fields. They all go off and get priced in some archaic underwriting system. And you come back with what is really a proxy for your risk. One of the things that we believe that we can do by getting people's raw data and understanding the things that actually affect your real risk. So how much attention do you pay? How do you drive in different driving conditions? Rather than unconscious proxies or bias. So things like, what is your postcode? Do you live in a high income area or a low income area? These kind of things don't really have an impact in how good a driver. You can be an excellent driver, and the fact that you're 24 and you live in a low income area and you've only had your license for 4 years doesn't really impact your risk as much as the fact that we can tell by the way you're driving that you drive very carefully. Whenever it rains, you drop your speed limit by 10 miles an hour, which means you're much less likely to have an accident. And if you're less likely to have an accident, then we're not going to have to pay out as much in the way of claims, so we can reduce your premiums. And so that's where I guess we are going with the technology and why telematics is so important to us. The biggest technical challenges that we have with all of this stuff is literally the volumes of data. People talk about big data in lots of different sense, and we've got tables with close to 1 billion rows in them for different policies and transactions. But 1 billion rows in a Postgres table is not really even that big a data. Once you start getting into, we are taking data points 60 times a second from 50,000 users and publishing that all to a server, and we want to run machine learning models and analytics over that to be able to provide data back to people in real time, that's when we start to get into the really interesting and fun bits, which is a lot of the challenges that we're solving at the moment. So they become about moving data around, pipelining, warehousing that data, making it available to our data scientists to train their models, and then putting those models into production to actually use them for pricing. We use a number of technologies, much like Tessian, we're a Python stack on AWS. So being Python really allows us to use the same technologies as our data scientists and our tech ops team. And so the entire stack all gets to utilize the same code bases, which is fun. It means we get to look at what other people are doing and really easily understand their code. But also means that we can interact and we can move around and help different teams. So what we're doing at the moment around this is making sure that we have the right engineers on the right teams and putting together these squads to be able to say, right, we've got a big push on food delivery. So COVID's obviously a very good example. The amount of drivers that Uber Eats and Deliveroo and Just Eat are onboarding at the moment is huge. So how can we really push towards getting those drivers the most amount of value from sharing that data with us? I've got no idea how I'm doing for time, by the way. I know we were running a little bit over late, um, but I basically just want to say that we we very passionately believe in making sure that the data that people give us is something that we not only treat with respect and treat with all the security that this kind of very personal data deserves, but is also treated like a currency. And if people are going to provide it to us, we need to be able to give back to them that same value. And that is a challenge that oh, Lawrence has just told me that I can keep running, so I can just keep talking. That is really a challenge that I thrive on because at the end of the day, no matter what we're doing as software engineers, it's about providing real value to our users. And from day one, when our users turned around and said, like, thank you for existing, I wouldn't have been able to work if I couldn't buy my insurance in this by the hour, to these days where people are saying, hey, thanks for telling me how I'm driving. Like, I thought I was a really good driver, but I'm scoring middling to below average. And I can see, like, we give people the feedback in real time. And we can see people's driving behavior really start to change. And if that causes not only people's insurance premiums to go down, but also people to have less accidents so they can continue working for longer, then that's fantastic and a win for everybody. I want to say, like everybody else, we're hiring. I'm pretty certain that Samuel's going to post a link to our profile on my tech tree. We are hiring a lot of. Oh, hang on, I've got a question. Yes, I love Q&A. Do you see on-device AI as an opportunity to reduce data bandwidth? If so, how much of a problem do you foresee model optimization to be? Yes and no. I believe that there is quite a lot that can be done with it. One of the big issues we have is that it's going to be used a lot more for processing the data on the device, but still sending it off. We're not able to take just the accelerometer data and the GPS data and use that to update your price. There's a lot more factors that go into it, but being able to provide real-time interactions to the user specifically for what we consider first notice of loss. So one of the biggest challenges in insurance is, do you have a gap between when an accident or an incident occurred and when that gets reported to the insurance company? And the longer that gap between an incident is, the more expensive claims are going to be. So being able to process that data on the device to properly understand, hey, this was a harsh break or a large bump, or this was an accident. And like I said, provide value back to the user to say something along the lines of, hey, is everything all right? Do you need us to call out an ambulance? Have you just had an incident? Like, we have support staff on hand that can help you with this thing, because quite often people are in a state of shock. So being able to do that on-device processing and optimization for incident notification, I think is definitely there. Would you use federated computing, Google research paper to build global models on the device? It's not something we've looked into. It's something that I know our data scientists were talking about in Slack. I think the specific paper that you're talking about, but it's not something we do at the moment. I could definitely see it being something useful, but I don't know quite enough about it to comment.